So Lee, we can start sharing, and while I'm trying to explain this to you. So everything that comes from the vision is actually passed through an AI. So the AI tried to analyze the image. So what is the object in the image? He tried to detect, okay, there is a desk, there is a wall, there is a door, there is a window, there is a possible human under the debris, or even under a concrete structure. So at the first, when the robot, before going through rescue site, many rescue sites, his training data will be not so perfect. But then, and the way that he navigates through the site will not be perfect also. His understanding of how he goes through the obstacles will not be perfect. By the time when the training data, he have more sensor information, he goes through many websites, many rescue sites. So it means that his analysis of every image that come to him, um, it will make him take a better decision than before. Okay, so it means that the AI keep accumulating experiences like the human mind. So it will navigate better, it will take a better decision, it will analyze the images in a much better way. So if he learn, so it means that he also learned by mistake. It means that at the first shot, maybe he cannot recognize there is a survivor here. But then he would discover, oh, he make a mistake in the previous rescue task. And then he will improve his analysis for the images that he take on the next coming tasks. Does this make sense to you?
Yep.
Okay, continue then.
Because, but that doesn't mean I should also get like the potential disadvantages as well.
Sorry, again, can you repeat it again, please?
So in other subjects, when it says like discuss, it generally involves like looking at both like pros and cons. So should I like write about it in that way here as well?
Yes, and you are actually doing it great. So your first part of the answer is excellent. Yes. So it's you just can add only that in addition to the last portion that you write here by making prediction, the time spent and it is reduced, and also this make best utilization of the available resources for the rescue team. So they only can focus on the possible places based on experience that they have seen from previous rescue sites, where survivors most probably can be located, or at least survivors that have a higher chance of actually surviving. Okay, so there is possible that you can find survivors, but then maybe you could waste time with people that is about to die actually. So one of the problems with AI that also maybe this is maybe part of the social and ethics. So um, the problem with AI is that sometimes the information and the training data or the data sets that is used to train the machine learning and the AI is biased in a way that, okay, so you will not find it, you will not find the data, especially if it is related to survivors, you will not find the data, you will not find the robot or the machine learning that is used on top of the robot trained on and all humans. So they will most probably they will use white people to train the data. So it means that you will always find um, biased decisions that is taking um, not taking into account every possible race. So if there is a rescue sites that have black people or maybe people from Asian origins and the white people, so you will find that um, the robot have a higher prediction or puts higher priority on the white people. This is a branch of the AI that is always discussed. So this is what they call it, a biased algorithm or even biased data set. The data set that they collect on training the robot, you will find most of it, 90% of it, is based on the white people. So the robot or the machine learning is actually somehow only act based on the training that is provided to him. So if the training and the data set that he's trained on only contain white people, so it means that uh, the way that he predict or deal with 9 white people will not be perfect actually. So that's why this is one of the social and ethics dealing with survivors. And also another way, uh, robot at the end is a piece of metal, so it have no emotions. So there must be a way that that we deal with survivors in a human way. So it's either when there is a human communication that need to be done. So the robot actually cannot act as a human, so he have no emotions. He cannot show empathy or he cannot show emotions to the survivors. So when there is a need for a human aspect, so there must be a ways like opening communication channel with the rescue team when the human person can really communicate with the survivor and to act in a human way. So that is a problem. And also that we must think of a way that we program the robots in a way that it can be safe for human. At the end, the robot is a piece of metal, and when it is dealing with a human that is full of meat and flesh, so we have to actually be very careful not to harm the humans instead of rescuing them. So this is part of the social and ethical things that we they need to be always mentioned when you are talking about this kind of aspect that need to be dealt with when dealing with robots, rescue robots. Did I make sense to you? Did you understand what I mean?
Yes.
Okay, perfect. So can we continue the remaining thing?
I mentioned like cost in here as well.
Sorry again. What did you say?
Cost. Could I mention cost in here?
Past means what is that? Sorry.
Cost, like cost, because I'd imagine like a distributed system would be more like expensive than a centralized system.
Yeah, definitely. Yes. So you need to talk about yes, it's a kind of comparison that you are trying to mention. So definitely you talk about cost and installation difficulty, upgrade difficulty, um, um, control wise, which one is more easier to maintain. So do you know, just let me get this. Do you know, if we talk about upgrade and installation, which one more easier, which one more difficult?
Oh wait, yeah, installation is easier for a distributed, I mean, sorry, yeah, distributed, but upgrade is more difficult for distributed.
Okay, okay, yeah. So, and again, if we talk about maintainability, so if you talk about maintenance or single point of failure, which one can survive a failure, the centralized or
Distributed.
distributed? Okay, good. Yes. Okay. So as you know, if the centralized, the central unit fails, so all the system goes down. But the distributed can still survive if one portion of the distributed control is offline. So this is an excellent answer. Just to highlight to you, also we can create a file with a list of MAC addresses. Do you know what's the meaning of a MAC address, right?
Yep.
So every hardware have a MAC address, like we know, and there is a setting inside the routers and even wireless devices that you can limit access by a MAC by the MAC address of the hardware. So if we have 10 devices and we are able to see the MAC addresses of each and put them in a file inside the wireless device, so only these devices or the computer with these MAC addresses are allowed actually to access the network. This is one way. A second way is to even hide the network ID. So if you don't see the wireless network, then you're not able to try to access it. So we can hide the network ID. So that is also in addition to what you mentioned here, authentication and encryption. Okay, so we can continue, please. So in short, you're also having an excellent answer, except that when you're talking about priorities, so you will tell that the operating system make a priority queue where we are having the tasks that have higher priority is running first. Other than that, you are perfect. So because we are running out of time, so yes, what you write here is actually correct. In addition to decoding instructions. So instructions, you know that this can be a part of your program that you write in Java. This is called instructions. And if we talk about cache memory, yes, your answer is also perfect. And you also should know that if we want to plan to get information from the RAM, so not only that the cache stores the most frequent used or most frequently used information or data, but it also act as a buffer. So it means that instead of reaching the RAM one shot, this cache act in the middle, so the information is stored in the cache here. So we know that we have a CPU here, and this CPU need to go, for example, and execute maybe 20 instructions. So it execute 2 or 3 or 4 instructions on every core on the CPU. And we know that, okay, we have next 19 instructions to actually fetch and execute. So the cache and the CU, the control unit, actually make sure that the information or the instructions, the 19 instructions that we plan to execute next, is actually fetched from the RAM into the cache and waiting for the CPU to actually take a toll and decode them and execute them. Did I make sense to you?
Yeah.
Okay, so I think by this we already finished today. See you tomorrow.
Yep. Thank
Take
you.
care. Bye-bye.